Let's build a function from a word problem. So let P be the point xy on the graph of y is equal to x squared minus 8. Let's express the distance from this point P to the point 0, -1 in the plane as a function of x. Then we're going to find the distance d if x is 0 and if x is -1. Then I want to graph the function d, and then I want to find the values of x for which d is the smallest. So let's start by graphing this function, y is equal to x squared minus 8. So we're just going to sketch this. I'm going to put it over here. So I'm going to make the x and y plane. Here's the x-axis, here's the y-axis. And notice that x squared, that's a parent function. F of x is equal to x squared. We can graph that. We know 3 points that it goes through. It goes through the origin 0, 0, because if you plug in 0, 0 squared is 0. Plug in 1, you get 1, and plug in -1, you get 1. So this graph, remember, it's U-shaped, something like that. And it goes through these 3 points. We know for sure. I'm just going to write them here. Now, notice that this function y is x squared minus 8. So in other words, y is equal to f of x minus 8. And this -8 is on the outside of the function, which means that this is the function x squared shifted down 8 units. So let's make some tick marks. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to move these 3 points down 8 units. So I'm going to put this one here, and now this is 0, -8. This 1, 1 becomes 1, -7. And this -1, 1 is now -1, -7. And we can draw the new function that goes through these points. It's going to look something like this. Oops. Let's make it a little bit better. I'm going to shift this point over a little bit. Okay, so we just took this graph and we moved it down 8 units. Now I'm going to erase this graph here. So this is our new graph y. And what I want to do is I want to find the distance, d, from a point P that's on this graph. So P is not a specific point. It could be any point on this graph. It could be, let's say, this point here. Let's call this point P. And I want to find the distance from that point to the point 0, -1. So 0, -1 is right here. Let me zoom in a little bit. And I want to write it as a function of x. So this point P, let me put over here that P is equal to xy. Okay, so how do we find the distance between 2 points? So from this point to this one, well, we're going to use the distance function. Recall that the distance function between P and Q, where P is the point xy, and Q is some other point. Well, in this case, it's going to be the point 0, -1. The distance between these two is the square root. You subtract the x coordinates and square them, and add to it the difference between the y coordinates squared. So let's clean this up. So the distance between P and Q is the square root. X minus 0 is just x, so you get x squared. And this is minus a negative, so it's plus 1 squared. Okay, so this is the distance between any point P and the point Q. where q is fixed. Now here, for this particular point P, I'm not telling you any relationship between x and y, but this could be any point in the plane, this point here. But I specifically want the point on this parabola. And what I want to do is I want to take this function d, and I want it to just have the variable x in it. In other words, I want to get rid of this y. I don't want any y's in my function, because that's what this problem says. Express the distance, d, from this point P to this point as a function of x. No, not as a function of x and y, just x. Okay, well, how can we rewrite y as a function of x? Well, notice that to figure out what y is for this point here, you plug in a value for x, and then your y is given to you from this equation here. For example, if we plug in 0, we get -8, and that's this number here, -8. So this y value is just x squared minus 8. So in other words, this point is the same thing as x comma x squared minus 8. So what I'm going to do is wherever I see a y in this equation, this formula here, I'm going to plug in x squared minus 8. So the distance between P and Q is the square root of x squared plus, well, here's the y, so we're going to plug in x squared minus 8 plus 1. Don't forget the plus 1 because it's y plus 1 squared. And now let's simplify this a little bit. This is the square root of x squared plus x squared minus 7 squared. Now you could FOIL this out if you want to. I'm just going to leave it like this. And this function, I'm going to call it a function of x because there's only the x variable in here. So we're going to say d, the distance between P and Q, is this function that depends on x. So that's what we want to define in part A. We wanted to write the distance from this point P to this point, which I'm calling Q, as a function of x, and this is the answer here. So let me circle this. Okay, let's look at part B. It says, what is the distance? What is the distance if x is equal to 0? So what is d? Well, this is a function that tells us the distance for any x value. So what we're going to do is we're going to plug in x is equal to 0 into this equation here. So for part B, for x is equal to 0, all we have to do is plug that in to this equation. So we get 0 squared plus 0 squared minus 7 squared, which is equal to, well, this is 0 plus -7 squared is 49. So we get the square root of 49, which is just 7. So when x is 0, the distance is 7. And we can actually see this on the graph here, because what we're doing, erase, go back. So what we're doing is we're letting P be this point. This is our P, because the x value, remember P is x comma y, and we're letting x be equal to 0. So when x is 0, we get the y value of -8. So P is a point on this graph, and so when x is 0, we get -8, so we get this point right here. And if we measure the distance between this point and this point, well, what do we get? 1, 2, 3, 4, 5, 6, 7. We have a distance of 7 units. It's just this straight line here, the length of the straight line between these 2 points. And that would be 7. Let's try to do part C. What is d if x is equal to -1? So I'm going to plug in -1 wherever I see an x. So this is where a -1 was, and also right here. And so we're going to get, let me erase this, -1 squared is 1, plus -1 squared is 1 minus 7. So that's -6 squared. So this is the square root of 37. Now if you want to get this is the exact answer, but if you want to get an estimate, you need a calculator for like a decimal estimate. What I'm going to do is I'm going to use this this website called Desmos. I really like this website, and then we're actually going to be able to graph with it. So desmos.com. Let's go to that. And it says use a graphing calculator. And what I'm going to put in here is I'm going to put square root of 37. And it tells me that it's 6.08. That's about the right answer. So let's write that. This is about 6.08. Okay. Let's see if that makes sense. Well, looking at this graph, where's my point P? So we're letting the x value of the point P be -1. So when x is -1, right here, we get the value -7 for y. So -1 comma -7, right? So we're trying to measure the distance between this point and this point. And that distance is what we found right here, 6.08. Does that make sense? Well, let's see. The distance from here to here is 7. We know that for sure. That's easy to calculate. And this point, you can see it's just like one up here, but we're not making we're making a straight line, but we're not it's not straight down. It's kind of at an angle here. So you could make a triangle, a right triangle, this side being 7, this side being 1, and that would give you the length of this side here. And it looks like it would be pretty close to 7. And it is, it's 6.08. All right, let's graph this function. So I want to graph d of x is equal to the square root of x squared plus x squared minus 7 squared. So what I'm going to do is I'm going to use this, this website, desmos.com, to graph this. Now you can use your if you have a TI-83 or 87, you can use a calculator to graph that. This website is really nice. It's going to show me what this graph looks like, and I'm going to show you exactly how to do that. Also, this graph, this function here, this is a square root function, but underneath it's got an x squared term, and this is going to be an x to the 4th term. So we can't actually graph this by shifting functions. This is not manipulating one of the parent functions we know. So we're going to need a graphing calculator to actually see what this looks like. So it's x squared plus x squared minus 7 squared. So let me erase this. Okay, so I'm going to put in square root, just SQRT, and I get a square root. Then I'm going to put x. And then, you know how you have the number 6 on your keyboard? Just hit Shift 6 and you'll go up and put a 2. And then right arrow over to kind of go down from that subscript, plus x squared minus 7. And we're going to square that, so up 6, and then put a 2 here. And this is our function d. So this is what that function looks like. If we graph the function, this is what we get. And notice that I have a relative maximum and 2 relative minimas. So we've done part D, we've graphed this, but now let's look at E. For what values of x is D the smallest? So looking at this function, this function gives me the values of D. So what I'm looking for is the range of this function D. And I want the smallest number in the range. So the range is the y values, and the lowest y value we have occurs here and here. So you can see if I click on this point at the minimum, I get that when x is negative 2.55, because that's what we're plugging in for x, D is going to be 2.598. And also when x is 2.55, we get 2.598. So let's write that down. So for this problem, when x is plus or minus 2.55, that's when D is the smallest. And that means that D is equal to, I think it was 2.598. So that would be the minimum value for D. Now let's see if that makes sense when we look at this graph here. Now this graph, oops, I want to erase this piece here. So we have this point, and what we're doing is we're measuring the distance from that point to any point on the graph. So 2 is somewhere around here, and I would think that the shortest line I could make from this point to this graph would be around somewhere around here, right? Which looks like it would occur around the x value 2, and it happens to be 2.55. Notice that if I go between, so this is -2 or -2.55. Of course, my graph is a sketch, so I'd have to be really careful to see where this crosses the x-axis. But let's put 2.55 over here. In between -2.55 and 2.55, so we have -1, 0, 1, and so on, things in between. Notice that for any of these x values, you would get a longer line. So for any point on this graph here, this line would get longer. And the longest it would get is right here at this point. When x is 0, we get -8. Remember that the length of this line, because that's the distance, we already found that. We said when x was 0, we plugged it in, we got 7. And then after we go past 0, these lines get a little bit shorter until we get to the shortest point, which is 2.55. Let's look at the graph and see how that relates. So at -2.55 here to 2.55, remember that this is telling me the distance from that point 0, -1 to the point on the graph. And you can see that the distances are getting bigger as we go from -2.55 in between these two. And once we get to 0, we have a distance of 7. So that corresponds to this point, this line right here. That's the longest line that's going to have a distance of 7. And then these distances are getting smaller. And then the smallest is when you get to about here, which was this 2.55. Then when you go past that x value, you get bigger than that, let's say 3, 4, 5, 6, 7. Well, notice that this graph is going up. So if we were to continue to draw this, like make it go up like this, you would see that as x goes further and further out, let's say right here, let me sketch this a little bit better. So this is going to keep going up and a little bit to the right. That's the idea anyway. That these points, if you choose a point here, the length of this line will start getting longer and longer. And so the further you go out with the x, and also if you go out this way, these lines will get longer and longer, which is why in this picture, if you zoom out, you can see that the distances are getting longer and longer.